Hello, everyone. In this video, I'm presenting the climate change mitigation and bioeconomy strategies of forest products. My name is Sheng Xie. I'm a postdoc working on the PICS Wildfire and Carbon project. I will start with an introduction on why forest products are important and their possible mitigation options. Then I'll talk about the results and highlights and wrap up after that. Forest removes carbon from the atmosphere through photosynthesis. Harvest activities transfer carbon from the forest to wood products until they are burned or decomposed. The delay of carbon release creates carbon storage. The delay is longer when wood is used for applications with long service life, while providing the forest with time and space to regenerate and remove more carbon from the atmosphere. In addition to that, wood products can further reduce emissions in other sectors by substituting emission-intensive materials such as steel and concrete in the construction sector and fossil fuels such as gasoline and diesel in the transportation sector. Displacement factor is commonly used to quantify the effectiveness of this mitigation benefit in a unit of emissions avoided per unit of additional wood used in substitution. If we graph the service lives and displacement factors of different end users to compare their mitigation potential qualitatively, we would find that structural and non-structural applications in the building sectors are among the best ways to utilize harvested biomass in terms of greenhouse gas mitigation. However, not all forest biomass is suitable for material uses. Energy utilization of low quality biomass may play key mitigation roles in the transportation sector. Transportation and building sectors are among the top emitters in BC. BC reports about 62 megatons of CO2e per year of emissions. The transportation sector contributed 40%, and the building sector contributed 13%. That is a total of 33 megatons of CO2e per year, which are over half of the reported emissions in BC. And the 2030 target is about 38 megatons of CO2e per year. But note that this figure does not include emissions from the forest sector. Forest sector emissions were consistent before 2003, but have substantial variations year by year after that due to fires and insects, which severely reduced the carbon sequestration ability of our forest. Cumulatively, our forest has become a carbon source. However, emissions from harvested wood products were consistent and cumulatively the largest component of forest sector emissions, which are accounted for 56% and were 1.5 times the emissions from fires. I would like to mention that fire has become increasingly important, and its emissions are projected to dominate very soon. Our current project, with collaboration among Pacific Institute for Climate Solutions, Canadian Forest Service, University of British Columbia, and US Forest Service, looks into a full suite of actions regarding wildfires management and bioeconomy. However, this topic is beyond the scope of this presentation. What I am presenting here seeks to quantify and identify future mitigation potentials of forest products through different biomass utilization and trade scenarios. BC is blessed with large forest resources, and in 2016, wood harvest contained carbon of 67 megatons of CO2e per year. As mentioned in the previous slide, reported anthropogenic emissions in BC are 62 megatons of CO2e per year. Therefore, our annual harvest contain carbon roughly the same as the annual reported emissions. This is an important message because this indicates that how we utilize and trade our harvest can have large effects on our emission profile. Currently, 37% of the biomass are converted into solid and composites wood products. 15% yielded as pulp and paper, and another 37% ended up as bioenergy. I would like to point out that black liquor, which is a byproduct from kraft pulping process that is burned for energy in the recovery boilers, is one of the major sources of biogenic emissions from wood products in BC. And we'll see that again in the later slide. BC is a major exporter with 90% of the products exported. Most of our solid wood goes to the US, pulp and paper goes to China, and pellets goes to Europe. The current internationally agreed accounting approach for the forest sector is production-based. So BC has to report emissions from exported wood products. Currently, about half of the carbon contained in current year's harvest are emitted immediately, and about 16 megatons are emitted from retired wood products that were harvested in the previous years, and resulting a net increase to the HWP carbon stock of 18 megatons. Now, by looking at these numbers, we were asking, are there ways to reduce our emissions through better utilization of our harvested biomass and export strategies? To answer that question, a harvested wood products carbon dynamics model specifically designed for mitigation analysis is required. This slide shows a helicopter view of the Mitigation model. The Mitigation model was built using the carbon budget modeling framework for harvested wood products, but expanded the design of the NFC Mars HWP carbon reporting model used for our national inventory reporting. For the interest of time, I'm not going to go into the details of the model structure, but to mention that the Mitigation modeled the interconnections along the wood products processing supply chain and go beyond the intermediate products, such as sawnwood and plywood, to end-use applications such as buildings, furniture, and fuels. As mentioned earlier, black liquor combustion in kraft pulp mills is one of the largest sources of biogenic emissions from harvested wood products, at 13 megatons of CO2e in 2016. Over 90% of which is associated with the production of pulp and paper for export. I also want to mention that the model has been actively enhanced and now has the ability to model fiber inputs of different quality, such as salvage logging and harvest residuals, in addition to conventional harvesting, as well as innovative products such as advanced biomaterials, although we did not specifically use them for this particular study. So to remind us that the purpose of this analysis is to conduct quantitative mitigation assessment of alternative harvested wood utilizations and trade. On that note, let's first take a look at the scenarios before jumping into the results. The x-axis of this figure shows the scenarios. We had a business as usual baseline scenario and two extreme scenarios that used all wood for construction or renewable fuel. These two scenarios will set the upper and lower boundaries of emissions, aka the bookends. We had a domestic demand driven by population scenario as the basis of all the inward and outward focused scenarios, which means the domestic demand needs to be fulfilled first before reallocating the remaining biomass. The domestic demand here refers to BC wood that is consumed in BC and other provinces in Canada. In the case of the next scenario, some of the remaining biomass was reallocated to the domestic building sector due to an assumed increase of wood building market share. And a scenario that prioritized feedstocks to renewable fuels. Moving on to the outward focused scenario, the first one prioritized the US and other markets for construction. The last two scenarios prioritized the Chinese market and the Europe's pellet market. The y-axis indicates the cumulative emissions from harvested wood products produced from 2016 to 2050, so 35 years. The net carbon storage can be viewed by comparing to the cumulative harvest amount. I would like to note that although the y-axis shows the cumulative data, I intentionally put average annual data in the brackets for easier comparison to BC's mitigation targets. The emission decrease or increase from harvested wood products of each mitigation scenario can be demonstrated by comparing to the baseline scenario. The numbers on top of each mitigation scenario indicate the percentage changes compared to the baseline. We can clearly see that in each scenario category, construction purpose results in greater benefits than the other options. Scenarios in the inward category all provided reduced emissions. This is because wood used in Canada has longer average service lives than foreign jurisdictions, with the exception of the US market. However, the inward scenarios does not vary significantly among themselves because the domestic market is small. The foreign market is larger, but if we cannot guarantee long-lived applications, the emissions can go up. Therefore, a construction-focused bioeconomy will provide highest biogenic emission reductions in harvested wood products. But if long-lived uses cannot be guaranteed, BC may be better off consume biomass domestically. I'd like to note that this figure only shows the direct carbon emission and storage in harvested wood products, and this is only a partial picture of the mitigation potential. Substitution benefits should be quantified as well. Now this figure includes substitution benefit. The average harvested wood products emissions in the baseline scenario is 40 megatons of CO2e per year. For the other mitigation scenarios, if the bar on the positive side is smaller compared to the baseline, that indicates reduced emissions from harvested wood products. And in this extreme example, 29 megatons of CO2e per year was reduced. The bar on the negative side shows the reduced emissions from other sectors, and in this scenario, it is on average 37 megatons of CO2e per year. Adding up the two gives the total mitigation benefits of 66 megatons of CO2e per year. Construction uses are indeed the most climatically efficient way of material utilization, even if BC cannot claim the substitution benefit in the global market due to accounting rules. This still provides the biggest bang for the buck from a climate perspective. However, for this strategy to work, we need to build equivalent to 10,000 Brock commas on an annual basis. And Brock commas is an 18-story hybrid mass timber building at University of British Columbia. For comparison, we only built equivalent to 200 Brock commas using BC wood in Canada at the moment, And BC wood is used to build equivalent to 1,800 broad commas in the US, Japan, and China. Now, if we look at the construction market worldwide, US and China are the only markets that have sufficient scale. Unlike burning black liquor to produce pulp for China or export wood pellets to Europe, producing biofuels and displace fossil fuels domestically would provide substitution benefits for Canada. For example, the all-fuel scenario would produce 9.3 billion liters per year based on pyrolysis and hydrothermal liquefaction technology, assuming these technologies are ready. However, it barely just meets BC's transportation fuel demand. I would like to mention again that the all cans and all fuel scenarios are extreme scenarios that provides the bookends, and we do not imply the future mitigation effort would ever achieve these values. However, the results of more realistic scenarios tell us the same message, even though the magnitude is not as high. Model runs reveal that under the current UNFCCC's accounting rules, there exists a threshold service life of 32 years for the exported products, below which the overseas storage becomes less beneficial than converting these exported biomass to liquid transportation fuels to substitute fossil fuels in the domestic region. For example, the weighted average service lives of BC wood in China is 6 years. The service life in Europe is close to 0 years due to their large pellet import. Therefore, there may exist a better strategy that combines construction and biofuel. And the mitigation potential of this inward-focused, construction-dominated, and biofuel-subordinated bioeconomy was examined. It is estimated that this strategy can reduce emissions of 3.5 megatons of CO2e per year from harvested wood products and 14 megatons of CO2e per year from other sectors. The total mitigation benefit is 17.5 megatons of CO2e per year, which is about 28% of BC's reported emissions in 2016, or 34% of BC's 2050 mitigation target. The mitigation benefit of this approach ranked the third best, only running after the all counts and all U counts scenario, which are considered to be difficult to attain, and we have explained that in the previous slide. To achieve the outcome of this scenario, BC can build the same floor area as at present, but the wood building market share needs to be doubled for the domestic market at the expense of concrete and steel. The international market shares were assumed to be unchanged. Now, redirecting low-quality biomass feedstock from overseas market is adequate to produce biofuels of 4.4 billion liters per year, which is about 50% of BC's current energy demand in the transportation sector. I would like to note that biofuels is what we assessed for this particular research, but the model is now capable of evaluating advanced biomaterials as well, which may offer higher economic returns, longer carbon retentions, and greater substitution benefits. Biofuels and bioenergy should be a last resort when no other options are available to us. So to wrap up, BC's harvested wood products emit about 40 to 50 megatons of CO2e per year. And our analysis show that how we use our harvest matters, and to where we export also matters. We have great opportunities to reduce emissions if we shift focus to longer-lived wood products such as mass timber. It requires greater domestic and international collaboration. And we should combine this with biofuels for uses that cannot be electrified. This bioeconomy would imply more value-added facilities such as CLT plants to be built, innovation on biofuels, and although not discussed here, high-value advanced biomaterials can also help diversify and extend the value-added chain and increase the resilience to the province's economy and possible rejuvenation of the rural communities. Last but not least, enhanced uses of biomass can also create opportunities to reduce future wildfire emissions. Finally, I would like to acknowledge that this project was funded by the Pacific Institute for Climate Solutions with outstanding support from Canadian Forest Service and UBC. Thank you.